is on solving special right triangles. Special right triangles are triangles that have measures of 45, 45, 90, and 30, 60, 90. This one right here is an isosceles right triangle. Let's visit that one first. So in a 45, 45, 90 triangle, the hypotenuse is the square root of 2 times as long as each leg. So that means, we look at this to the right. Let's look at an example. There's going to be 2 different examples I'll come up with real quick. Right? So say I have a 45, 45, 90. And this one's also a 45, 45, 90. If I know the length of one of the legs, I can easily find the length of the other leg, because if it's isosceles, those have to be congruent. So if this is 8, this has to be 8 as well. All right, so I'm just plugging in for x. If I know x is 8, that's 8 as well. The hypotenuse is just 8 times the square root of 2. Okay. If I'm given the hypotenuse, say the hypotenuse is 12. Say the hypotenuse is 12. Now I'm going to go backwards and find the legs. Remember this. I want to find the legs and give them the hypotenuse. So if given the hypotenuse, divide by 2 and multiply by the square root of 2, find the legs. All right. So I have the hypotenuse now. I want to go backwards and find that these 2 legs. What's half of 12? 6 root 2. 6 root 2. Done. All right. So now if I have one side length of a 45, 45, 90 triangle, I can find the other 2 very quickly. Next, let's go ahead and look at examples A and B before we move on. All right? So take a second, see if we can find x and y here, or the value of x there, and then we'll move on using our shortcut method, not Pythagorean theorem. All right, so this first one, example A, I have a 45, 45, 90. So this is an isosceles right triangle. So if this value is 3, y has to equal 3 as well. And then what x is? I take 3, the length of a leg, multiply by square root of 2. All done. Next one. I'm given the hypotenuse. I want to figure out the length of one of the legs. Remember what I told you. Take the hypotenuse, divide by 2 times the square root of 2. Done. One way, an alternate way to go ahead and tackle this, right, is I know my 45, 45, 90 triangle has these properties. These two are the same. Hypotenuse is x root 2. So whatever I'm given, I can go ahead and set that equal to this formula. And then if I solve for x, I get 5 over the square root of 2. And if I rationalize it, I end up with that. So it saves you a step if you can remember that simple rule. If you're given the hypotenuse of a 45, 45, 90 triangle, to find the length of one of the legs, divide by 2, multiply by the square root of 2. All right, so let's take a look at 30, 60, 90 triangles. All right. in a 30-69 triangle, the hypotenuse is twice as long as the shorter leg, the opposite 30, and the longer leg root is root 3 times as long as the shorter leg. So the first thing we need to do is be able to talk about the same things. So I'm going to label this across from the 30. That is my short leg. The hypotenuse is always across from the right end. And then this other one is what we call the long leg. So we have the same idea here. We have our short leg, x. Our hypotenuse, which is twice the short leg. And the long leg, which is short leg times the square root of 3. One way to memorize these, right, is notice this has a 30, this one has a 3. So 3 and 30. This root 2 is the other one. Okay? So let's go ahead and see the 3 different types of situations you're going to be given here. Let me erase this for right now, give me some space. And I'll show you how these work. Well, let me move this over. All right, so 3 different types of situations. That we'll have. All right. So I have my 30, 60, 90 triangles. The very first thing I'm going to do is, let's go ahead and label our short leg. Our long leg. And then our hypotenuse. All right. So let's consider the 3 different situations we can be given. Remember, we're going to be given one side, and we want to be able to solve for the other 2. So the easiest one is when I'm given the short leg. JV, give me a number, any of
37.
37. So if the short leg is 37, the hypotenuse is twice 37. 2 times 37 is 74. And then this long leg is just whatever the short leg is times the square root of 3. Done.
Wait.
Well, that's it. If we're given the short leg, double it to find the hypotenuse, and multiply by root 3 to find the long leg. The next situation, which is also quite easy. What if the hypotenuse was 12? Okay.
And the short leg is 6.
The short leg is half of 12, or 6. And then once I have the short leg, the long leg is 6 root 3. Pretty easy, right? Once you get the practice and develop the pattern. We're doing a lot of practice in class, so I can run around and help you till we get this. The only tricky one is, what if I'm given the long leg? And remember what I told you when we were dealing with the 45, 45, 90.
Yeah.
Right? If given that hypotenuse, the one that has the root 2, we divide it by 2 and multiply by root 2. So if I'm given the long leg, to find the short leg, divide by 3 now, and multiply by the square root of 3. A little bit tricky, but not too bad. Right? This has a 3 in the square root. So if I'm given this is 9, to find the short leg, what's 9 divided by 3? 3 times the square root. And then 2 times 3 root 3 is 6 times the square root. 6 times the square root. It's just a pattern. And this might seem a little bit tricky right now, but as we get more and more practice at it, it's going to be like, oh, hooray, it's a special right triangle. Bing, bing, bing. Okay? So let's look at the example. Let's look at this first example. Example C. First thing I'm going to do with these as I'm starting to learn. Label our short leg, our hypotenuse, and the long leg. Let's decide what we have. Do I have the x, the 2x, or the x root 3?
You have
The x root 3, that long leg. So what I want to do is divide by 3 times square root of 3 to find this. So this is going to be 5 over 3 times the square root of 3. There's my x. The y is going to be twice that, so 2 times 5 root 3 over 3, or just 10 root 3 over 3. Take a second. Try letter D. So, all right, so this one, I have, let's label these, short leg, hypotenuse, long leg. I have the hypotenuse, so can I easily find the short leg? Short leg is half the hypotenuse, so 22 divided by 2, 11. And once I have the short leg, this thing all wraps itself up. 11 times the square root of 3 is the long leg. Yes.
Okay, so isn't the 5 is half of it? And how come, like, not the 22 is half of it, right? Then how come the 5 is
22 is twice the short leg. All right, next example. Whoa, smartboard math. So I have an equilateral triangle, which I know is a 60, 60, 60 triangle. So the height that I need to find the area is going to bisect that top angle, making it a 30, 60, 90. So now, label each. There's my short leg. There's my hypotenuse. There's my long leg. So if this is equilateral, I want to use 1/2 base times height. I know the base is going to be 6 since all the sides are the same. So now I want to figure out what that height is. So if I have the hypotenuse, half the hypotenuse, 3, and that height is 3 square root 3. And then I can plug those two in. So the area is to be 1/2 times 6 times 3 root 3. Half of 6 is 3. 3 times 3 is 9 root 3 centimeters squared. There's my area. The next one, I want to figure out the area of this parallelogram. Area is base times height. Hooray, I'm given the base, which is 5. Now I want to figure out this height. So if that's 4, there's a right angle right there. That's my hypotenuse. There's my short leg. Half of the hypotenuse is the short leg, so that's 2. And this height, which I want to find, is 2 times the square root of 3. And there's my height. So the area is 5 times 2 root 3, or 10 root 3 meters squared. All right, so now for this figure below, I want to figure out the area and perimeter. So let's go through this. If this is 14, this is 14 down here as well. And if that's 5, this is 5 over here. And then I have a 45, 45, 90 that isosceles right now. So that's 5, this is 5. What is this hypotenuse then? 5 times the square root. Now my perimeter, let's do area first, right? So the area here is length times width. This is 1/2 base times height. So I have the area of this little thing is 5 times 14 plus 1/2 5 times 5. Or 70 plus half of 25 is 12.5. We get 82.5. Now my perimeter, adding these up as I go around, 5 plus 14 plus 5 root 2 plus 5 plus 14. So what I'm going to do is go ahead and combine all the ones that don't involve a radical. So I get 19 plus 19 is 38 plus 5 root 2. See if I'm right. Oh, that's in the simplest radical form when we combine radicals.